Welcome everyone. It's super encouraging to see so many serialization enthusiasts in the audience. So I'm Viktor Klang, and I'm going to present the current state of the art for what we call marshalling, which is to be thought about as sort of serialization 2.0. And of course, it's a pretty broad topic, so in 50 minutes we won't be able to cover all that could be covered when we talk about this topic. So more specifically, I'm going to try to talk about what we're thinking about the API design, versioning, important topic, security, also a very important topic, some history, like why are we doing this, and some of the underlying machinery. And let's see how far we can get there. But of course, there are other topics that are super exciting and interesting, but won't be able to be covered in the time slot. But I'm very happy to talk about those things outside of the session later. All right, so just to be clear, and since we're talking about superseding a feature from the 90s, I figured I'd have the disclaimer be inspired by the 90s as well. So what I'm going to show you and discuss is my current work in progress. And this is a work in progress, so just making sure that everybody's on board with this. So serialization 1.0, you can think of it as a teleportation feature. And why are we doing a 2.0? Are we also doing a teleportation feature? Well, looking at the context in which serialization 1.0 was created, this was mid to late 90s. Distributed objects was the thing, the hype at the time. And it was really about creating something where you could take your object and you could send it to some other JVM somewhere else and have it retain its structure, its identity, and all of the good things about the object. Turns out, though, that teleporting things is really difficult. So if you have a running engine in your JVM and you want to move that running engine to another JVM, and still be a running engine when it returns or arrives at the other JVM, then that is a really tricky problem to solve in general. Also, it's a very potentially dangerous thing to do, because if that other VM is not happy about having engines running, turning up there, then that could be a problem. So it's important that we evaluate serialization 1.0 from a historical context, but also things have changed in the past 30 years. So perhaps we don't need to solve the problem of teleportation. Perhaps there's a differently shaped problem that we can actually solve in a better way. And at the time when this feature was created, serialization 1.0 that is, I don't think anybody knew what kind of implications it would have. So every single feature, or be it in the language or in the JDK, over the last 30 years, has had to be able to answer the question, what about serialization? So when you add this new class, what about serialization? When you add this new language feature, what about serialization? And serialization sort of cuts through everything. So it's a very impactful feature in terms of how many people need to consider it and how often it needs to be considered. So I won't delve too deep into this, but I think it's important to try to keep a bit of a tab on what kind of issues that we ran into. So some of the questionable moves were, it sort of pretends to be a library feature, but it isn't, because it isn't implemented in the library. I mean, transient is a language keyword, so it's sort of a language and library feature, but also it's not necessarily implemented strictly in the library either, because it sort of circumvents a bunch of things that we'll discuss later. So it's a weird kind of feature that you can't necessarily place anywhere. It also pretends to be a statically typed feature, like I implement serializable, but it really isn't. Oh, sorry. So you have these magical methods that you need to implement. And given that they are magical methods and they're not a part of the serializable interface, the compiler won't help you. So you have magical method names with magical signatures that you need to make sure to implement correctly, and the compiler doesn't help you. And of course, just the mere fact that there are magical method names can be problematic, because what if you misspell the name? What if you don't remember what the name is? How do you even find it? Do you need to go online and search for, like, what are the method signatures that I should be looking into here? So that has a discoverability problem as well. Also, serialization primarily concerns itself with reading and writing things. And reading and writing things is woefully imperative. You write this, you write that, you read this, you read that. And also, you need to keep those things in sync. So if I'm reading that, then I should have written that, right? So it needs, both you have to do it imperatively, but also you need to keep it in sync. So that also means that since you're dealing with these streams, you have a tight coupling with the actual underlying representation, what actually ends up being the serialized payload. You can't necessarily switch that out for something else. So if you wanted to have your serialized representation be JSON or XML or Proto or whatever it might be, you are sort of locked into a single representation. I won't go too deep into this, but can anybody raise their hand if they feel like they are somewhat familiar with the actual serialization format? Anyone? Do I need my... We have 1, 2, 3, 4. Do we have 5? 5? We have 5 people in the room. Great. Direct questions to those. So, and this is one of my pet peeves. So you have a class, and you need to extend that class, and unfortunately, the author of that class has marked it as serializable. And now you're also serializable. And you can't say that, well, perhaps it made sense for certain parts of the hierarchy, but it doesn't make sense for me because I represent some database connection or file handle or something. And it sort of means that you are resorting to have to throw exceptions or otherwise try to prevent your class from being attempted to be serialized. And we have Stuart, my colleague here in the audience, who knows full well what kinds of issues you might run into when you try to preserve cycles in object hierarchies or object graphs. And it is related to the notion of identities. So in order to preserve the identity across a cycle, you need to remember that identity across the cycle. But there are a bunch of edge cases where it's not necessarily clear how you would ever be able to serialize something. And reconstituting it might be problematic as well. So I think, and this is just a suspicion, but I think it is almost impossible to try to do this perfectly. And if you can't do it perfectly, how do you know when you can do it and when you can't do it? And also, it's not the person who writes the serializable representation that constructs the graph. It's the user of that thing. So it's sort of weird responsibility division there. All right, so what are the consequences with all of these choices? Well, we have a challenge because it undermines encapsulation. So when you serialize an object, it doesn't go through the front door of that object and goes through access control and it does the right thing, but it really sort of reaches into that object and does what it needs to do. So it sort of passes by the encapsulation model that we're used to as Java developers. But that also undermines security, and we'll well, I have a couple of slides on the security aspects because personally I think that's one of the most important aspects. So we'll dive deeper into that shortly. And as I said before, if you have a feature that intersects with almost everything else, then every single change that you want to do has an implication on this, and you need to take care of it. So it really provides a bit of a challenge for evolving the platform. Of course, that translates to library maintenance as well. So you need to keep track of, okay, so does this change the representation? Should I update the serial version UID? There's all kinds of decisions that you need to make when you're maintaining an API or a library as well. So one of the bigger things here is undermining the object integrity. So if you look at a pull request of a Java class that is implementing serializable, and you see that it has defined a read object and a read resolve, and it has some read object no data method, how many in the audience know the order in which these methods are invoked by heart? So like if I ask you now, you will be able to respond. Do we have one? I'm not sure we have one. So that is actually a problem, because if you have somebody on the other side reviewing this, then how are you sure that it does what you expect it to do? And that makes it really difficult to work with. And also, objects are deserialized by magic and not by going through their constructors. And I will show you what that magic, or discuss what that magic is shortly. But that turns out to be a big problem as well. So, going into the security domain here, one of the problem is what I call off-label construction, or some people call off-label construction, which is when you create an object without invoking its constructor, and then you're poking in values into the fields, and you're bypassing all the whatever logic is defined for that type itself. And while it makes it possible to recreate an object, because if you can get all the values out by breaking in and scraping it out and putting it on the wire and then poking it back into a newly, freshly created thing that didn't have its constructor invoked, then you sort of can do what you wanted to do. But the problem is, where do you actually put your validation logic, and what happens with things like final fields, etc.? So the solution here, if we wanted to do something differently, I think the solution here is to just say that we will always go through constructors. So even if you have a factory method, that typically bottoms out at a constructor. If you return a static instance, that has gone through a constructor. So everything sort of bottoms out at a constructor. And that makes it much clearer to understand how objects are created and validated. Another issue, I don't know if you're familiar, but when you want to deserialize an object and you have your object input stream and you do read object, you're not specifying what kind of thing that you're expecting. It doesn't really take a parameter saying that I'm expecting a foo.class, or I'm expecting a list of strings or something like that. And that means that the payload says, okay, I have a whatever, and then you can only check after the fact that, oh, this isn't what I was thinking I was getting, but then you've already deserialized something that could potentially be maliciously created or even corrupted. So, and then it's too late because you've already constructed it. So I think relying solely on the payload being the source of truth is a potential recipe for problems. So I think what we need to do there is, at least we need to be able to specify what we're expecting, so that if whatever is provided can never match that, then we don't even touch that. So at least we can rule out a lot of potential results that wouldn't make sense, even be it for logic issues or be it for malicious reasons, right? This one might be a big one. There is if you have a class and you implement serializable, you need to mark things as transient in order for them not to end up in the serialized payload. So you need to opt out of participating, which means that if you add a field that could potentially include some sort of vulnerable information or protected information or something like that, you need to be really clear about marking that as transient, right? But it's sort of a problem waiting to happen if you're not sure how this works. So how do we avoid that? Well, I think the solution is pretty clear. You just change the default. You have to opt in to put things in an external representation. At least you've made the choice, and you've made the choice explicitly. So at least it can be code reviewed and say, oh, why are we putting that on the wire? So I think that is a good way of dealing with that. And of course, access busting, which is essentially disregarding access control. So if you can just reach into an instance and do whatever thing you want and pull out field values and you can poke field values back in, then you have a pretty brittle security model for it as well. So the solution here should be pretty evident that if you have internal state that is not accessible from the outside, then the class author itself needs to delegate that access and say that I'm fine with you accessing this from the outside. So there is an explicit opt-in, and that can be tracked and code reviewed. So I call this the opacity problem. This is my mental model of serialization. So we have a class, we have instance of that class, we write that using write object on object output stream. It results in some data in the serialization format, and then on the other side, we're reading that data with an object input stream. We get the instance recreated, and then, of course, that instance belongs to the right class that was serialized in the first place. But for me personally, I feel like I see the things, I see the instance, and then when I put it in write object, and then it sort of goes away, then I can't see what's going on. And then on the other side, I'm just reading it. So this pretty difficult to figure out what's going on in there. So it's pretty opaque. So the realization here for marshalling was, if we need to go through constructors in order to recreate objects, we need the inverse of that. Right? So we have constructors in the model, but we don't have a defined means of, oh, how do I extract the data representation of this thing? We need the mirror image. Because if we have both of those, then we can take an instance, extract its data, and then pass that data into its constructor, and thus we have recreated it. So we need to be able to extract the data. So marshalling, you could think of, in a way, is deconstruction plus reconstruction. Because we already have construction internally, right? We have constructors for objects, but we need to be able to take the information out of it and recreate it potentially somewhere else. But I think that is the wrong mental model here. Because it's not necessarily about the mechanics of how do you deconstruct something and how do you reconstruct something. It's about the following. It's about bringing the external structure of something into the programming model. So it's about the data representation, not necessarily only the mechanics of how do I get this from A to B, but it's really about what is my external structure, my external representation. Because that ties those two things together. Because if they can agree on what the external structure is, then we can transform it into that, and we can transform it from that. So what if we were to take some inspiration from records here, sort of lean into it a bit? So we can define a simple record point that has a x and y coordinate, which is an int. So that's pretty standard practice, right? And we can create instances because we get this default canonical constructor, and we can get an instance from a point. Then we can use record patterns, and we can extract the point, the individual coordinates from the point. So we have those again. And then we can recreate a new point with those exact values. So we created the instance, we then extracted the data, and then we recreated the instance. So we're not trying to preserve the identity of the thing, we're trying to preserve the representation of the thing, the structure of the thing. Of course, these two should be equal. So if we take this analogy and sort of say, okay, so what happens if we try to marshal a point? What does that even mean? So what if it means you have some data output stream, and we have some destination for that data output stream, and we essentially take our point and we extract the coordinates, and then we write those coordinates as ints to that data output stream. Does this make sense? This is just, we're deconstructing the point when we're passing the data that we got out of our point into our data output stream. So that is sort of the high-level idea here. What if we could do this? And on the reading side, we would just read from where we wrote, but using a data input stream instead. And then we would just read two ints. And of course, we would need to make sure that we were putting them in the right place. But fortunately here, we're writing them in the same order that we're reading them in, right? So now we can create this sort of manual marshalling, your experiment marshalling here. And of course, these two should also equal. But now we've been able to take something and potentially putting it on the network or on a file or in a database and be able to recreate it. But any takers as to what this represents? Point? Cheating a bit. Of course it's a point. So that is the bit representation of the 10 and 20 of that thing. But if you just received a file that had this information, how would you figure out what to do with it? What does it mean? It's like getting a packet of unassembled thing without instruction as to how to recreate it. It's like, yeah, I can see that it's stuff, but what do I do with the stuff? So one important component here is there are different ways of representing data on the wire. And sometimes you need to include the information about what the representation is inside the payload itself. So we're calling this schemas, and it's essentially a blueprint for how to interpret instances of a type. So this is just a case in point where we, no pun intended, right? But we're getting the schema for marshalling of point out. So what does that schema include? Well, it includes the owner of the schema, which is the point class. It has two parameters. The first one is an int. The second one is an int. The first name is named X, and the second one is named Y. And then we have a nifty descriptor string, which also happens to be very amenable to including in bytecode as a constant. So there's a sort of a unified format for representing those as strings, but it's not strictly that. But the important part here is that we have metadata about points. We can now reason about what a point means in terms of a marshaled representation. So we know that if we have a marshaled representation of a point, it has two parameters. The first one is an int, the second one is an int, the first one is named X, the second one is named Y. And why is that important? Well, because there are wire formats that are positional only, so there are no names included. Think of like flat files or something like that. And then you have formats that are nominal, primarily, like JSON, where you have attribute names being the primary thing and the order is not the primary thing. And then you have things that have both, for redundancy or not. So having this representation here means that you can support a much larger array of potential wire formats for these payloads, because you have both names, types, and order. So I gave a presentation, I think it was earlier this year, which was how marshalling looked like at the point at that time. And the key feature here was we had an intermediate representation called structured data that was an immutable representation. Think of a snapshot of an object graph. And once you've made the snapshot of the object graph, you could sort of pass that into something that transform that snapshot into an XML file or a JSON document or whatever. But it turns out that that has some drawbacks. So I'll just walk through this quickly. So with marshalling, the class author should be in charge of what the representation of the class should be, or instances of that class. And marshalling is responsible for extracting that representation and transforming it into structured data in this old model. And then we had a complete decoupling between the snapshot and whatever goes into the wire and out of the wire, and then you recreate it on the other side, so you have a nice sort of handoff point. And then you could just unmarshal it on the other side and you recreate it, so you run it in reverse. So the good thing about this model is that you have this really clean handoff. There is no interaction between the consumer of the snapshot and the producer of the snapshot. So that's a benefit. There's a stable, reusable snapshot, and there's a clear separation of concerns. But it also has a few drawbacks, because it's really costly and difficult to avoid boxing when you have this intermediate representation that could be a bunch of primitives in all kinds of ways. And you're also having to create the entire thing before you can actually transform it into another representation. So you have this larger resident memory usage. So that's clearly a trade-off. And those in the audience can sort of see the trade-off here between batching and streaming, right? So if you need the full batch before you can process it, then of course it's going to have trade-offs. So the updated design that we're looking at right now is slightly different. So class author is still in charge, and the marshalling is essentially the deconstruction and passing that into something else that transforms it, and I'll show you later. So there's a separation here. I don't know if it's a good analogy, but saying that if you have a company and you process orders and your order processing has an XML format, you don't have XML. You have your schema for specific XML for your specific use case, and that is what I call the domain format. That is the usage of XML in this context. It has a very specific structure. You can't put any tags you just want to have there. It needs to follow some sort of definition. So here we want to be able to take objects defined in Java and be able to transform them into essentially anything, be it XML or JSON or whatnot. But there's typically always a translation layer between the object and JSON, because there are multiple ways that you could represent a single object as JSON. Sometimes you might want to have things be JSON arrays, or sometimes you might want to have things as nested objects. There are different sort of data design concerns regarding these things. So we've sort of simplified this so that there is a handoff between them. We don't have this clear separation anymore where the domain or the wire format consumes the structure representation, but we're essentially passing the information in a streaming fashion instead. So I/O is now a part of this pipeline, because you need to have a destination of the streaming information. But the cool thing is that if you want to, you could actually have that destination be an in-memory representation of the graph. So you can sort of create the batching model in the streaming model if you want to. So what is the thing that takes a class and extracts the information and passes that into a consumer of the exploded part of the object, all the individual components? So this is currently called a marshaller, and we have a bunch of methods on it. So I'm just including this for ease of understanding of what we're dealing with here. And it has a bunch of methods. You will probably understand why they're all there, because if we want to preserve primitives and not box them, then clearly we're going to have some overloads here and manually specialize these things. But think of it as a different kind of output stream. That's a simple way of looking at it. And on the other side, we have an unmarshaller, which is a different kind of input stream. And here, highlighted, when we want to unmarshal an object, we always specify what we are expecting so that we can communicate that information down into the parser of the format such that we don't create things that don't necessarily need to be created. And of course, we have a bunch of these as well, because you might want to represent primitives in your payloads as well. So how do we make an example out of this? So if we want to extend the analogy of we're doing this manually, then imagine that we have some sort of custom JSON marshaller. That is your domain format. You have a custom definition of JSON that you're creating for points for some reason. You're a huge fan of points, and you want to represent them as JSON. Then what we could do if we wanted to do this manually is to say, okay, so I create a marshaller, and that has some sort of output destination for the marshalling, and then I want to unpack the point manually because we're doing this manually, but we still want it to be able to say what the payload actually is, because the format may want to retain that information. You remember the long string of zeros and ones. It would be nice to have some sort of header that says that, hey, by the way, this is a point. So in order to do that, just imagine that you're able to manually construct, because we're doing this manually, we're able to manually construct a schema that we want to write, and then we say, okay, here comes this structure representation, and then we manually send in our ints x and y, and then we say, okay, we're now done officially with this object, and we have done this manually, and we have communicated what we were trying to write and the actual values that we were trying to write. So that makes it easier, because now we can sort of embed the type information if we needed to. And on the other, if our custom JSON marshaller had a text representation, it might do something like that. So, hey, I want to embed the type information in the payload. I have a text representation of the schema, and here are my values. It doesn't need to, but it could. And on the other side, of course, if we have this payload and we want to unmarshal it manually, then we would essentially say that, oh, now we need a custom JSON unmarshaller. There's a typo. Nice to find that now. And we would just essentially do this in reverse, right? We would still have to say, okay, what are we expecting in terms of schema? Because if we're trying to unmarshal something that wasn't intended to be points, we definitely want to know about it and not create bad points. So we say that, okay, we want to unmarshal this thing, give me 2 ints, and then I'm done with my unmarshalling. And now we've sort of manually marshaled this. But this is not super exciting, right? I don't feel like there's like a very high level of excitement here, right? So now we get into the fun stuff. So that was like trying to do marshalling-ish things manually, but the interesting thing here is how could we do it automatically? So what are we trying to automate? So on the marshalling side, we're trying to automate the extraction of the state representation from the instance. And then we want to obtain and relay the schema used for those values. And then we want to pass the state representation and the schema, and we want to be able to say that, okay, we're not done. We want to automate this entire process. And on the unmarshalling side, we want to say that, okay, you wanted a point. We want to make sure that we have a point. And then we want to figure out, okay, you want a point. Are there multiple representations of point? What kind of version of point do I have, and how do I unmarshal that? So figure out what the schema is and unmarshal it according to that schema, and then invoke the reconstruction logic, like the constructor, etc., and pass in those pieces of information. So that's what we're sort of trying to automate here. But how do we automate something that we don't know how that actually looks from a programming model point of view? Because right now, up until this point, no pun intended again, but we've only dealt with records. And it's pretty easy to see how records are sort of perfect as data carriers, because they have all of this contextual information about what their components are, what the names of the components are, what the types are, the accessors, all the good stuff. But clearly, it would be very limiting if marshalling only supported records. So how do we define classes that are marshalable? So this is trying to project the point as a class instead of a record, omitting a lot of methods. And imagine that we are declaring a record internally within point. And we could name it v1. Doesn't really matter. v1 is a good name, I think. And then we say that, oh, this is a structural representation. So this is a schema record for point. And I can derive the schema from this record definition. That would be nice, because I don't have names for the parameters of the constructor, because those are not reified unless you compile with dash parameters, and those will be reified for the entire compilation unit. So this is now a way of saying that, okay, this is what my structure looks like for version 1. So how do we go from point to v1? So I have a point, but I want its structural representation. Well, I create a constructor that takes a point. And then I get the values out, and now I have a function from point to point v1. So now I can go from instance to structure. And on the other side, if I have a v1, I can just have a method on it that essentially invokes the constructor, saying that, okay, I can recreate a point given a v1. So now I have a function in both directions. So I can go from point to v1, from v1 to point. So now we can sort of go through the entire process of deconstruction and reconstruction. So how do we figure out what sort of schema records are available for point? Well, if we want to try to marshal a point, we can just scan point and see, okay, does it have any defined schema records? And I can figure out what the current one is, because it could be multiple. Imagine that you have older versions that you want to support. And then we can take those schema records and we can generate schemas from them. And then we can generate logic that takes the instance of point, creates a point v1 from that, and then essentially splices the components into invocations of marshal int, marshal boolean, marshal object, so that we can have a transformation from a record to a series of marshaller calls. So now we have a full transformation from an instance into a series of output stream-ish calls. And then, of course, we need to remember this and say that, oh, you were trying to marshal point before. We've already done all this work, so let's just reuse the thing that we already have. So essentially, if you think about it, you have this big map of types to some sort of pair of, and this is perhaps needlessly complicated, but not all classes may want to be marshalable, but they may want to be unmarshalable, depending on if you have a asymmetric or symmetric system. So on one side, you only unmarshal things, and on one side, you only marshal things. But it's important here that there's only one current version. There's only one current structure. Because otherwise, it would be very difficult to figure out how to generate recursively a complete object graph. Like, what versions should you use? Like random for every single thing? That would be extremely difficult to figure out. So, if we then have these schema records, then if they are not public, or if the type itself is not public, then how would we ever be able to access it? So we were talking about the access busting before. How do we make sure that we can opt into, hey, it's fine if you scan the internals of this class because I'm the class author and I authorize this? Well, we have a single registration call in a static initializer that says, hey, it's fine, you can look at this class. And we have some safeguards to make sure that only the right class can call it in the right place. So we can see here below that we can find the marshallable schema for point class even if v1 was protected, and that was not because we were breaking in, it was because the class author had said that that was okay. Whew. All right. So we can now have a single version of a structure inside of a class. Wow, that's amazing. Well, clearly, there's going to be evolution of structure. We're going to add fields to classes. We're going to remove fields from classes. So it's important to have a versioning story. So funnily enough, if you have an old version, so in this case, we are adding a new coordinate here. We're now a 3D point. We're no longer a 2D point. We have evolved. So we have deprecated the initial constructor because we don't want people to create 2D points for our nice 3D point anymore. And we have also deprecated the structure that only had the two values. So now we can define a new structure that has all of the values that we want to have. And we can figure out that, hey, everything except one thing here is deprecated, so clearly this is something that is current. So that is an indicator that we could use. But this also means that you have places where the versions are sort of self-contained. So if you decide at some point, no pun intended for like the 4th time or something, then if you don't want to support a version anymore, you just remove the record. It's very self-contained. There's not much code sprawl in terms of, oh, I need to make edits in several places, but it's really about removing a single class within a class. And also, how does this work with inheritance, right? So if I want to extend a class, so let's say that we have a point, but its fields are now private for some reason, and we have a schema record for this type, and we want to create an even better version of point that extends point. So we decided that adding the 3rd coordinate there wasn't all good, so we're extending instead. So we have this great point here. And how do we, I mean, we're still defining a version 1 for great point. So we have a version 1 for point, now we want to have a version 1 for great point. How do we get the values, the structure out of point? Because remember before, X and Y, they're private. So how do we get the values out? We're the subclass, but we can't access it. Well, we already defined that, right? We have a point v1. And this is completely 100% analogous to linking against a super constructor. So this is the analogous thing of connecting to a super constructor, but instead of for construction, it's for deconstruction, getting the values out. So we can now get the values, and we can pass that in. So if point ever deprecates v1, then the compiler that compiles greatpoint will actually get a warning saying that, hey, you're now linking against a version that is no longer current. You should probably update in time. So we can sort of use pre-existing mechanics to figure this out. So if we put all of this together, we create a new point, and we have our sort of custom JSON marshaller thing. We only need to do this as a user that wants to marshal a point. We create the marshaller that we want. It could be an XML one, it could be a JSON one, it could be a CSV one, could be whatever. And the logic for how to represent points as data is defined by points class author. And as a user, you can just pass it into the marshaller, and the marshaller itself will get all of the information passed to it because we've auto-generated that translation from the instance to its components and values. And on the reading side, it's the same thing. We can just unmarshal, but we specify what we're expecting so that we're not unmarshalling stuff that we don't want. So these two should be equal as well. So let's see here. Where are we on time? 5 minutes left. Interestingly, of course, you want this to happen. So if you were expecting something that wasn't there, you want an exception. And this is something that works as the prototype stands now. So it's pretty flexible in that regard. So the essence of marshalling, we're trying to center this around data, not necessarily the behavior itself, but really about how do we expose this in the programming model so that people can reason about the structure of their classes. We want to minimize the magic. We want to have as few magical things as possible and try to reuse and leverage what the language and the platform is already offering. And we want to focus on the transformation from the external structure and back. So the key thing is the data, and secondly is the transformations. And we have arrived at an encoding in this prototype where we can really leverage factories or constructors, because the unmarshal method could call a factory if it wanted to. You could also put an additional, more thorough validation when you're unmarshalling something versus whether you're only creating it from a constructor. So you can have an extra security layer in there. And also, we're eschewing supporting circularity and preserving identities inside this actual thing. Now, if somebody wants to use some sort of cache and try to map some inherent identifiers of things and do that, they can probably do that on top. But the thing is that if you guarantee that at the lowest level, then you can never get away from it. And also, we have means now to delegate access and not go in without checking the guarantees provided by the platform. And most importantly here, we have now decoupled the actual wire format from this entire machinery, so that people can experiment with their own wire formats. Library authors can adapt to or integrate with this and provide support for that. So that means that it's way more flexible to have a single structural representation, and you can have code in the same process that transforms something to both JSON and XML or what have you. So very, very powerful in that regard. And of course, the benefits that we get here, hopefully, right, in the future. We don't need transient anymore. There's no serial version UID. The list is so long that I couldn't even fit it on the slide, and I didn't want to make the font super small. There's lots of potential benefits here by just redefining what the feature is. When it's no longer teleportation, we can now choose what is more suitable for modern workloads and using everything that we've learned over the past 30 years. So serialization was created for a different purpose, and now we can create something that is for a more modern purpose. So where are we in terms of how this is going? Well, there are a bunch of stuff left to do, but just shortly, we want to decide on the set of primitives. Are arrays automatically supported, or are collections automatically supported? What does it mean to be primitive when it comes to structure? We want to decide what the initial set of JDK supported marshallable classes, what they are, how many of them there should be. The good thing about marshalling is that it's not locked down, so that you can incrementally add more support. So that's one of the benefits. Of course, this is a moving target, so making sure that it works well with value types. Also, what happens, should there be a bridge between marshalling and serialization or not? Is there a migration path? What's the recommended migration path? And of course, there are some exotic data structures like lambdas, etc., that we'll have to look at and see how that works. So, and then of course, last but not least, at some point there will probably, hopefully, be a JEP drafted. And that's all I had for today, so thank you.